In this video, we're going to talk about the binomial distribution. So here the binomial is basically the following thing. So if you can want to take a picture of it, or if you want to just pause the video to write this out, please do so. So the binomial distribution is just an experiment that follows, an experiment that follows the binomial distribution is binomial if it satisfies the following requirements. So it follows a binomial if this is true. So it has to be binary. That means there only has to be two outcomes. It has to be independent, so that means that one occurrence is not going to affect the other. N, it means that the number of trials is fixed, and S means that it has the same probability all throughout. So the way that I kind of remember it is with the keywords bins. So that kind of helps me remember the four different things that this binomial distribution has to have. So one good example of a binomial distribution would be maybe flipping a coin, because when you flip a coin, you have two different outcomes. You can do this many different times. One event does not affect the other, and every single time that you flip it, you're always going to have the same probability. Okay, now how do you find the probability in general? Because if you flip the coin 100 or 1,000 times, and you want to find the probability that half of them were heads, there's no way that you're going to be able to do that all by hand. So we do have a really crazy formula right here, which you can choose to write, but we're not going to use it, okay? Instead, what we're going to do is we're going to use our calculator, because if you really wanted to figure out this probability, it would just take a very long time. Also, it has factorials in them. There's a lot of different things that here that is very algebraically. And if n gets really large, you maybe don't want to compute this factorial stuff. So what we're going to do instead, we're going to use the calculator. So what I really want you to do on Canvas, please access the binomial distribution steps. So it'll look something like this. So if you see here, it says finding binomial probabilities. I have it for the TI-36X Pro. Here are the steps on how to do it, on how to use binomial PDF and binomial CDF. And then if you scroll a little bit down, whoa, I wrote it and I didn't want to write. And if you keep going a little bit down, I have it also for the graphing calculator. So here are the steps as well. So I would suggest go into your into Canvas to access this thing. And I'll be going off the computer and also to my calculator so you guys can see how we solve these problems. So, whoops, that's not it. So now what we want to do, I'm going to show you an example of what this kind of looks like. So something that you do need to figure out is that n is going to be the number of trials. Okay, that usually is going to be given to you on the problem. Okay. P is going to be the probability of success. That's what P is. And then finally, X is going to be the number of successes. Okay, so that's what we have. So don't worry so much about these factorials. If you really want to, you can just go ahead and exit it. Basically, what the calculator is going to do is going to do all of this in the calculator instead of doing it by hand. So what we're going to do an example. A couple things to note, because there's two functions that we're going to be looking at. So the first one is binomial PDF. Okay, you're going to have an n, p, and x. And the other one is going to be binomial CDF. Okay, same thing, n, p, and x. Okay, so when you have a binomial PDF, you want to be able to look for the word exactly. Okay, so exactly one number. So usually when we talk about binomial PDF, you think about probability of x equaling 3 or probability of x equaling 4. That's when you use binomial PDF. So it'll tell you the probability of exactly that point occurring. Now, binomial CDF, you only want to do it when it's less than, okay, or less than or equal to. Okay, so when you have that, that's when you want to be able to do it. So when you have probability of x being less than 3, probability of x being less than or equal to 4, something like that. Okay, when you have these symbols, or when the problem tells you something is less than. Now you might be wondering, okay, well, there's one thing that's left over. What about greater than? Well, the thing about greater than is that, so if you have something that's greater than or greater than or equal to, okay, so if you have this, then in that case, the probability of x being greater than or equal to some number, maybe a, well, you can't quite do that in the calculator. Instead, you have to be very creative. So what you would do, you're going to do 1 minus the probability of x being less than a, okay? And if you have the probability of x being greater than a, you're going to do 1 minus the probability of x being less than or equal to a. Okay, so this is what it's going to be. This is basically the gist of it. You want to be able to do problems that look like this. And you want to always look for the keywords, and the keywords are not always going to be the best. Well, they are going to be good. It's just translating them to math is, I think, what's the toughest part. Knowing if it's included or not included. So you might be wondering why this is true. Basically, remember that all of the probability is equal to 1. If it's included here, I'm going to subtract all the probability that's less than this particular amount and not included. That's going to give me the other probability. Okay, so if you quite don't understand it, it's okay. Just you have to be able to do some of the problems. As long as you have this, you'll be able to do it. So just know binomial PDF is when it's exactly. Binomial CDF is when it's going to be a less than or less than or equal to, and then greater than or equal to. This is what you're going to use. So in the next video, what I'm going to do is I'm going to do an actual problem.